Good morning. Welcome, Lutheran Church of the Resurrection. So glad to see you today. My name is Jeff. I'm one of the pastors. We are so delighted to have our fourth annual Fall Speaker Series. And yesterday we had an event where we had a 40-minute tour of time and space. And so we solved everything yesterday. So thanks for coming, and we'll see you tomorrow. There's quite a bit more to say and quite a bit more out there, but we had a great introduction. And I think yesterday I read a list of Grace's appointments, and they weren't all at the same time. True. From everywhere from the University of Chicago to the Planetary Science Institute, where she is currently senior scientist and senior education and communication specialist. Also talked about the fact that since 2016, she has served as vice president of the Center for Advanced Study in Religion and Science. Most importantly, yesterday, we learned that you were an accomplished ice skater and a Star Trek fan. So it is with great pleasure that I once again introduce to you Dr. Grace Wolfe Chase.
Oh, thank you so much, Pastor Jeff. So I want to start by thanking all the wonderful people I've met since yesterday, the wonderful people of the Living Legacy Committee to whom we owe this event and other events like this. I'm so honored to be part of the series. Pastor Jeff, Pastor Nate, Carrie, Ramon, the people behind the scenes who are doing the tech stuff. Thank you all so very much. I'm humbled and honored to be here. I also want to acknowledge that we're on the ancestral lands of the Sauk and the Meskwaki peoples and pay respect to their elders, both past and present, who are the original stewards of this land and are still connected to the territory. Yesterday evening, we took a whirlwind tour of the universe in time and space, told folks a little bit about myself, and we're going to slow things down a little bit today and examine more closely how our views of the universe interact with the way we think about God. So first I'm going to suggest a couple of caveats on the title of today's presentation. I don't think infinite is a big enough adjective to describe God, and I think this quote by Sarah Maitland argues this point very well. Greg Cantor was the first to prove that there could be a series of infinities, that infinities come in an infinite number of sizes. Thus, Cantor's absolute is a perfect image for what we experience of God. When I speak of a big enough God, I am not merely thinking of an infinite God, but the God of infinities, the absolute, which either chooses to reveal itself or remains veiled in mystery. She goes on to say, modern mathematics does begin to feel like the language that God talks. I'm not sure about the implied analogy of God as a mathematician, as beautiful as mathematics is, but I love the point of this quote, and it reminds me of the language my colleague, Gail Woloshak, who holds double degrees in biology and Orthodox theology, uses. Gail has talked about early Christian negative theology, which would describe God as not big, emphasizing God's transcendence and the inadequacy of human language to describe God. So although we're focusing on astronomy, more generally conversations are framed around science and faith, or science and religion, or science and theology, where these words actually mean very different things. My friend and colleague, the late Father George Coyne of the Vatican Observatory, saw faith as a gift from God and noted that we don't reason our way to faith. Religion embodies the practices of one's faith, and theology is faith seeking understanding. So just as science seeks to understand the natural world, theology seeks to understand, or at the least explicate, talk about things relating to God. Now, I'll probably use these words interchangeably, people do, but I wanted at least to make that distinction. And now I apologize for repetition with last night, but I think it is important that those of you who weren't here last night learn a little bit about me. I come from a very small, all-female family. I was born in New York City, raised in New Jersey by my mother and maternal grandmother during the 1960s and 1970s. And informal education played a much larger role in steering me towards a career in the sciences, notably Star Trek. My passions during childhood were, as Pastor Jeff said, figure skating, astronomy, and science fiction. And I think the original Star Trek series may be largely what motivated me into a career in astronomy. Today, as an astronomer and a Lutheran Christian, I find that science fiction can also stimulate religious and ethical discussions by placing contemporary issues in an alien context. So we're talking about aliens, not necessarily us. A number of years ago, we had an adult forum at my church, St. Paul Lutheran in Wheaton, Illinois, where we read biblical parables, and we were asked to consider the question, with whom do you identify in this story? Since that can depend upon a person's experiences, their culture, their place in society, even how you're feeling on a particular day. So I think of many science fiction stories as kind of modern-day parables, and really quickly, I want to offer up a few of those parables to you today. The first of these aired during the original Star Trek television series in 1969, the year after Martin Luther King Jr. was assassinated. It provided a very obvious commentary on racism and where hate leads. The second aired in 1992 in the Star Trek The Next Generation episode, The Outcast. It explored gender identity by introducing a genderless society that considered identifying with any gender to be deviant, and those who did were forcibly reconditioned. The third aired pre-Star Trek in 1962 in what might be the most famous Twilight Zone episode of all time. In this story, an alien species comes to Earth with promises of sharing its advanced technology, and it brings along a book with the seemingly benevolent title, To Serve Man. Unfortunately, during the last 15 seconds of the episode, we learn that To Serve Man is a cookbook. Chances are everyone would be horrified at the thought, I know I am, at the thought of human beings treated as livestock by another species. But what if we were placed in the role of being the technologically superior species? Food for thought. So stories or parables often ask us to think about our perspectives and assumptions a little more deeply. So science fiction is one place where science, theology, and ethics meet. When the movie The Martian first came out, my colleagues and I loved this quote that was given to Matt Damon. I'm going to have to science the expletive out of this. What we loved about this quote is that he used science as a verb, and that's really what science is. It's a process by which we solve problems. The methods used by science have been very successful in revealing how nature works. Now, it might surprise some people to know that the word scientist was only first used in the 1800s. In the practice of science as we do it today, making and testing hypotheses with observations and/or experiments, and then developing theories that make testable predictions, that systematic practice only goes back about 500 years or so. The most successful theories have withstood rigorous testing. They're consistent with what we know about nature across many different scientific disciplines, but they're always limited in scope. So today, the space sciences include many branches. Astronomy and astrophysics deal with the material universe beyond Earth's atmosphere, and these terms tend to be used interchangeably today. So whether you call me an astronomer or an astrophysicist, I'll respond to either one, whatever you like. Astrochemistry is the study of the abundance and reaction of atoms and molecules in the universe and how they interact with radiation. Cosmology reconstructs the past history of the universe to understand what we see today and to predict where the universe might be headed. Astrobiology is the study of life in the universe, its origins, evolution, distribution, and future, and it includes life on Earth. Astrobiology and planetary science are both multidisciplinary fields that combine physics, chemistry, biology, geology, atmospheric science, you name it, to characterize planetary environments and to explore what kind of worlds might have environments that could sustain life. Now, even as all of these fields have become more specialized, they've become more and more interdisciplinary, leading to larger and larger collaborations between scientists that have both overlapping and complementary expertise. When I was in graduate school, back when the dinosaurs roamed the earth, astronomers who studied space beyond our solar system and planetary scientists who studied the planets that orbit our sun rarely interacted at scientific conferences. And this started to change when we saw evidence that stars and planets form together, and we started to discover planets that orbit stars that aren't our sun. So today we speak of multi-messenger astronomy, where we get information from space across the electromagnetic spectrum, not just visible light. My own research makes use of, I know that that's very difficult to see from up there, but the electromagnetic spectrum goes from gamma rays through radio waves. And my own research makes use primarily of invisible light at infrared, microwave, and radio wavelengths, because we need those wavelengths to study the cold clouds that don't shine visibly yet, the cold clouds that collapse through gravity to form new stars and planets. We also put some telescopes in space because our atmosphere is opaque to many of these wavelengths, so we have to get above our atmosphere to study them. So we also get information from high-energy particles like bits of atoms, like protons and electrons, that arrive from energetic events that happen in space. And gravitational waves were predicted by Einstein's general theory of relativity in 1915, but only first recorded 100 years later, because it took that long to have the technology to actually record these minute ripples in space-time, which is what gravitational waves are. More about that in a little bit. So here's a beautiful photograph of the Milky Way in the night sky. There are increasingly fewer places in the world where you can actually see the Milky Way in all its glory. The terminology is a little confusing, since our sun and all the stars you see in the sky and many more that you don't see belong to an enormous group that we also call the Milky Way galaxy. Now, you don't look up in the sky and see the Milky Way galaxy because we're inside it. But you'll notice here dark areas. I guess I don't need the pointer because I have the arrows up there. Dark areas in the plane of our galaxy. Now, those are the places where the gas and dust in our galaxy is so thick that they block the light from stars behind them. These are also the places where new stars are born. So for me, my research is primarily interested in all that dark stuff in the Milky Way. And the fuzzy pink patches highlight stellar nurseries where the brightest new stars light up their environments. This overlay is from the Spitzer Space Telescope, which observed the Milky Way in infrared light. It uses visible colors to represent infrared light that's invisible to our eyes. Pretty much everything that's dark in visible light is bright in infrared light. And if you look at this stuff that's colored green, you could probably barely see it from the back of the room there, but this stuff that's colored green in that image is produced by complex molecules that pervade interstellar space. I've chosen this particular image to illustrate the different kinds of information we get from different types of light, and because this image is one that I've worked with a lot in my own research on star birth. And by the way, I'm going to tell you what my favorite star is, like I did last night. It's this star in Scorpius, Antares, and the reason it's my favorite star is because some of you may know that Nichelle Nichols had an absolutely beautiful voice, and in her role as Lieutenant Uhura on the original Star Trek series, she sang this beautiful song, Beyond Antares. And I was 8 when I first heard that song, but it stuck with me my entire life. So one of the places where faith and science meet is through awe, wonder, and mystery. And I'd like to give you some examples of awe and wonder in scripture and in religious thinking and also in scientific thinking. So let me briefly read the psalm. When I look at your heavens, the work of your fingers, the moon and the stars that you have established, what are human beings that you are mindful of them, mortals that you care for them? And from Job, can you bind the chains of the Pleiades or loose the cords of Orion? Do you know the ordinances of the heavens? Can you establish their rule on earth? Abraham Joshua Heschel writes this in A Philosophy of Judaism: the surest way to suppress our ability to understand the meaning of God and the importance of worship is to take things for granted. Indifference to the sublime wonder of living is the root of sin. You hear many similar sentiments expressed by notable scientists, such as Stephen Hawking, who says, what is it that breathes fire into the equations and makes a universe for them to describe? The usual approach of science constructing a mathematical model cannot answer the question of why there should be a universe for the model to describe. Why does the universe go to all the bother of existing? Why indeed? Freeman Dyson, another notable theoretical physicist: it is true that we emerged in the universe by chance, but the idea of chance is itself only a cover for our ignorance. I do not feel like an alien in this universe. The more I examine the universe and the details of its architecture, the more evidence I find that the universe must, in some sense, have known we were coming. Albert Einstein: the finest emotion of which we are capable is the mystic emotion. Herein lies the germ of all art and all true science. Anyone to whom this feeling is alien, who is no longer capable of wonderment and lives in a state of fear, is a dead man. Nobel Prize physicist, my New Jersey R's are coming to the fore here, Arthur Schawlow. It seems to me that when confronted with the marvels of life and the universe, one must ask why and not just how. The only possible answers are religious. I find a need for God in the universe and in my own life. And then there are these wonderful gentlemen of the Vatican Observatory. Science is sometimes accused of destroying wonder and mystery. However, for many of us, it does the exact opposite. It deepens wonder and mystery. For people who affirm God as the source of everything, which, by the way, includes science itself, it can also deepen faith. And some of us see science as a form of worship, like the Jesuit astronomers of the Vatican Observatory, whom I came to know during graduate school at the University of Arizona. These were the first people I'd met who were both outstanding scientists and people who thought deeply about their own faith. They've had a profound influence on me over the years. They see their scientific vocations as one way of worshiping God. In fact, the motto of the Vatican Observatory translates from Latin as "Come, let us adore God the Creator." A friend of mine, retired ELCA minister, Pastor Bruce Booher, illustrates some of these points through cartoons. So I'm going to read you just a couple of cartoons here. So this one young woman is saying, the problem with scientists is that you take the wonder and beauty out of everything by trying to analyze it. Scientist runs in, dude, my plasmoidal slime molds have heightened pigment production. Check out that yellow color. That actually makes them zinc resistant. Amazing, huh? First person, looks like dog barf. Scientist, yeah, F. septica is nicknamed dog vomit, slime mold. Cool, huh? So the first person, okay, never mind. What's wrong with scientists is that you do see wonder and beauty in everything. One more cartoon. One young man saying to the other, trying to tell him how to go and find a rainbow. The primary arc always forms at 42 degrees around the anti-solar point. So we need rain or mist off in one direction and the sun in the other. But the sun needs to be less than 42 degrees, about 2 shakahands from the horizon. His friend says, whoa. See, science doesn't replace wonder. It just tells you how to find it. And in the last frame here, why don't I feel the same wonder when I just Google pictures of rainbows? Even with science, more is not always better. And I'm here to tell you folks that if you have never actually experienced a total solar eclipse, put that on your bucket list. That's an experience that you will never experience by looking at photos of total solar eclipses. So people of faith and scientists have a lot in common, and these two groups actually overlap significantly. So where do problems arise? Well, one place they sometimes arise is that words we use in one context can mean something different when we use them in a different context. And of course, that can be a real problem when we're talking to people from different backgrounds or across different cultures. And here's just one example with the word creation that really refers to something different when we're speaking from a position of faith and when we use it scientifically. And that doesn't mean that one contradicts the other. It just means that we're referring to different things. So faith, we affirm God as the source and sustainer of creation, regardless of how we describe things coming to be. Science explores the nature, evolution, and creation of the material universe. That's what creation means in a scientific sense. Faith is concerned with God's relationship to everything in the cosmos, including us. Science is concerned with how things in nature are related to each other. Faith addresses purpose and meaning in existence. Science investigates the way things behave, not what they mean. Now, the distinctions I'm offering here are a bit simplistic, and I'll be the first to admit that there are borders today where science, philosophy, and theology become kind of fuzzy. But I think it's important to acknowledge that words and gestures are used differently in different contexts. So here you have banged up dog saying to his friend, "Did you know that when a cat wags its tail, it means something completely different?" Beware. So you may often hear that science can prove or disprove the existence of God, that science and religion have always been at war, and that you can't believe in God and accept explanations provided by modern science, like cosmic and biological evolution. All of the above are false. The third point, by virtue of the fact that there are many people who do believe in God and accept the process and results of modern science. So let's look a little bit about what science can and can't explain. I like to say that science is good at describing nature. Maybe describing is a better word than explaining. Describing how things come to be, how they behave and interact, how they change and evolve. And the success of science in learning about nature is demonstrated through advances in technology that operate on scientific principles and theories. And technology also extends the reach of what we can do through science. The reason it took 100 years to discover gravitational waves after they were predicted is we didn't have the technology. What sorts of things can't science explain? Lots of things, starting with science itself. We don't know why the universe is so rational and why we can understand so much about it. Hearkening back to that quote I showed you by Stephen Hawking, we don't know why there is a universe that we can describe with mathematical laws in the first place. Science creates models of reality, Models are not the same thing as what they model, as the underlying reality. And although science can tell us a lot about how nature, including how human beings behave, it can't tell us how we should behave. I would argue that science should inform ethical decisions, but that's different from dictating ethics. Science has occasionally been misused. In the late 19th and early 20th centuries, an idea known as social Darwinism misapplied the theory of evolution to sociology, economics, and politics to justify imperialism, racism, and to discourage intervention and reform. And that's a great example of the misuse of a scientific theory to do what it does not have the power to do. Religion and science have not always been at war. Modern historians have rejected what has come to be known as the conflict thesis or the warfare model and shown that that does not accurately describe how religion and science have interacted through the centuries. In fact, science, theology, philosophy have interacted in many fruitful ways through history. The relationship between science and religion has always been complicated by other things, like politics, like big human egos. The more things change, the more they stay the same. Politics and big egos had a lot to do with what went down between Galileo and the Catholic Church. And if you want to hear a fascinating story, I suggest you invite Brother Guy Consolmagno to come out and speak to you about this, because it is a fascinating history between Galileo and the Catholic Church. Several years ago, I participated in a summer program for high school students at Gustavus Adolphus College, where I co-led a class about vocation with theology professor Marcia Bunge. Marcia had a bunch of posters of famous Lutheran theologians like Martin Luther, and I had posters of scientists who also happened to be clergy members or other people of faith. And I want to introduce you to just a few of these people. Here are two Catholic priests who contributed a lot to our current understanding of the universe. Angelo Secchi is sometimes known as the father of astrophysics, and Georges Lemaitre is sometimes known as the father of the Big Bang. Now, we'll talk about their actual contributions more in a bit, but for now, I just want to read this quote by Angelo Secchi. "Spectral studies of celestial bodies are not aimed just at curiosity, but from them it depends the solution of many important cosmic questions. The first and the most important one is to recognize the nature of the matter composing the atmosphere of the celestial bodies." As we'll see in a few minutes, Angelo Secchi kind of turned astronomy from a study of how things move in space to a study of what they're actually made of. Two other people, Jocelyn Bell, a prominent person in the Quaker tradition, and the first female president of the Institute of Physics, discovered a very dense star known as a pulsar. A teaspoonful of a pulsar would weigh a few billion tons, comparable to the weight of Mount Everest, give or take. Stars much more massive than our sun can end their lives after exploding in what we call supernovae and leave behind these very, very dense stars called pulsars. As I mentioned earlier, our sun is a star in this very large group of stars we call the Milky Way galaxy, but we've also discovered a great many galaxies beyond the Milky Way. The study of supernova explosions in other galaxies are very important in helping astronomers establish the distance to galaxies, as well as measuring the expansion and the age of the universe, which we'll talk about in a bit. A Methodist minister named Robert Evans holds the world record of discovering the largest number of supernovae. Sadly, he passed away in 2022. He was what you might call a citizen scientist. And this man had an incredible memory, along with a large backyard telescope in New South Wales, Australia. And he memorized the environments of more than 1,000 galaxies to check for the appearance of these so-called new stars. When these stars exploded, they become very, very bright. He was made an honorary member of the Royal Astronomical Society of Canada. And my good friend, Brother Guy Consolmagno, the retired director of the Vatican Observatory. He curates largest meteorite collection in the world at the Vatican. He's credited with over 200 scientific publications, including several popular books. And in 2014, he won the Carl Sagan Medal for excellence in communicating science to the public while maintaining an active science career. Here are some more friends of mine. These scientists, ones depicted here, are all specifically Christian, and they're just a few of the many that I know personally, except for Catherine Hayhoe, who's a climate scientist, and she's been very active in evangelical Christian communities. Jennifer Wiseman, up there in the upper left, studies star formation, similar to what I do. She's the former director of a program called the Dialogue on Science, Ethics, and Religion at the American Association for the Advancement of Science. Gail Woloschak, I mentioned earlier, has double degrees in biology and theology. And Reverend Lucas Mix is an astrobiologist and Episcopalian priest. And one of the things he did was compile a volume called the Astrobiology Primer, which helps scientists talk to other scientists across different disciplines. In different scientific disciplines, we use different jargons, acronyms, methods. And the Astrobiology Primer helps biologists talk to chemists and physicists to come together on these big questions like, does life exist elsewhere in the universe? And by the way, there are also a lot of scientists who are devout in other faiths as well. So what's the problem? So one of the problems is we often want easy answers to holding science and religion together, but I'm sorry, I'm here to tell you they don't exist. Our scientific and religious understandings are both limited, and we need a humble approach in all of our discussions about science and religion. The second point here is perhaps the most important takeaway message I want to make over the few days that I'm here. When either science or religion is used as a weapon to attack the other, everyone loses. When young people who might be thinking about a career in science, might be very talented, are afraid that science threatens their faith, they often don't pursue that career. The other side of the coin, young people flock away from the church when they feel that faith is out of touch with today's world. So this is a point I think to remember. Tensions between faith and science are inevitable. However, many conflicts are tied to different interpretations of Scripture. So I'd like to go through some of the ways our thinking about the universe has changed in time and how that relates to some of the biblical stories. So the universe as portrayed in Genesis 1, the structure of the universe reflects the Babylonian picture of the universe that goes back to about 1700 BCE, where the universe was pictured as a three-tiered structure with a firmament of the sky, the stars and heavens, with waters above, the earth below, and then Hades or Sheol below. And when the floodgates were opened, it allowed water above to fall on the earth below. Now, the universe actually kind of looks like a planetarium. I worked at a planetarium for a long time. But of course, the significant difference between the story in Genesis 1 and other creation stories where the universe comes about through wars between the gods is that Genesis 1 says, okay, is this the picture of the universe? God did it. Our God is the source of everything, and it's very good. Creation is very good. There are many passages in the Hebrew Scriptures that sort of reflect this ancient cosmology. This is a list that my friend Phil Hefner, a Lutheran theologian, put together for an adult forum at my church years ago. Not going to go through them, just to be aware that the language used appears many, many times in ancient scriptures. So models of the universe change through time. The working model during Jesus' time was Aristotle's universe that pictured the earth either at the center or the bottom of the universe, depending upon how you want to think about it. Because the earth had all the mundane things, and then the heavenly spheres surrounded the earth, and the highest sphere was the sphere of the prime mover, Aristotle's version of God, which is very different from the earlier picture. So what have prominent Christian thinkers had to say about this? And in advance of showing you this, I'm going to tell you that these words are very harsh. And they're not my words. They're the words of St. Augustine more than 1,600 years ago, where he said, "It is a disgraceful and dangerous thing for an infidel to hear a Christian, while presumably giving the meaning of Holy Scriptures, talking nonsense. We should take all means to prevent such an embarrassing situation in which people show up vast ignorance in a Christian and laugh it to scorn if they find a Christian mistaken in a field which they themselves know well, and hear him maintaining his foolish opinions about the Scriptures. How then are they going to believe those Scriptures in matters concerning the resurrection of the dead, the hope of eternal life, and the kingdom of heaven?" Over 1,600 years ago, the words of St. Augustine. A millennia after that, we have John Calvin speaking on astronomy. Astronomy is not only pleasant, but also very useful to be known. It cannot be denied that this art unfolds the admirable wisdom of God. This study is not to be reprobated, nor this science to be condemned, because some frantic persons are wont boldly to reject whatever is unknown to them. And our friend Galileo. So Galileo's observations provided the first real substantial evidence that the Earth was not at the center, at least of our solar system. So in the Copernican view, the sun is at the center, and then the planets, including Earth, orbit the sun. Galileo writes, "To prohibit the whole science of Copernicus would be to censure 100 passages of Holy Scripture which teach us that the glory and greatness of Almighty God are marvelously discerned in all his works and divinely read in the open book of heaven." And I want to be clear that despite his problems with the Catholic Church, Galileo remained a devout Catholic throughout his life. And one put down between Galileo and the Catholic Church is really a shining example of how religion and science get entangled with other things. Big egos were involved with the whole debate. So I only have a cursory knowledge of this, but Brother Guy Consolmagno is the person to deliver a lecture on this. So I'd like to note also that this period of time is more or less really begins the science is how it's practiced today, with the extensive testing of hypotheses and with observations or experiments, and developing theories that actually make predictions we can test. Now, throughout history, ideas about how the universe is constructed have influenced the way people think about God. So in Isaac Newton's time, the universe was envisioned sort of as a large mechanism, where space, like in, I guess, the Shakespearean quote about the earth being an empty stage and people its actors, well, in this mechanistic universe, space was like an empty stage that provided an absolute frame of reference for the material cosmos that was composed of individual things. And the material world behaved strictly in terms of causes and effects, kind of like a clockwork universe. And gravity was envisioned as a force acting between matter. Now, unfortunately, this mechanistic thinking gave rise to thinking about God as some kind of giant cosmic engineer, and to what's known as God of the gaps theology, where God competes with scientific explanations. So it's either science has explained how this happens, or God did it. And that makes God's role smaller as our scientific understanding grows. Putting science into competition with God. Many people today, I think part of the problem is still think about God in this way, although our thinking about the universe has changed considerably over the past century. Today, the universe seems better described as an interacting web of relationships rather than a collection of isolated things. Two 20th century branches of physics revolutionized our understanding of the universe. Quantum mechanics, that describes interactions at the levels of atoms and subatomic particles, and general relativity, that describes interactions that govern the large-scale structure and evolution of the universe. More and more we hear metaphors from biology, such as nature and nurture, applied to the physical world, like in my studies of the birth of stars and planets. So the title of this talk uses the word immeasurable to describe the universe, and that's true in the sense that every question we answer about the universe raises even more questions. However, the universe has also been remarkably understandable to us. And theologians have seen this understandability as reflecting the rationality of God and our ability to learn and understand things about the universe as part of what it might mean to bear the image of God. So let's take a deeper look at some of the things we've learned about the universe. By the late 19th century, astronomy became not just about how things move in space, like the orbits of planets, but also about their composition. And that's what effectively turned astronomy into astrophysics. This Jesuit priest, Angelo Secchi, had an important hand in that. Among many other contributions to science, he built and used a spectroscope, which is a device that spreads light into its component colors, like a prism or a diffraction grating. He used his spectroscope to study patterns of dark lines that appeared in the spectra of different stars. He understood that those patterns were related to composition. However, at the time, there was no theoretical framework for understanding how those patterns were actually produced. Enter the 20th century, where quantum mechanics could be applied to understanding them through the interaction between light and atoms. And this woman, Cecilia Payne, was able to relate stellar spectra to temperature and composition, and she determined that stars, including our sun, are mostly hydrogen. Now, her work was initially met with resistance, partly because hydrogen is so rare on Earth, but also because she was a woman in a very male-dominated field. However, a few years down the road, the astronomer Otto Struve referred to her dissertation as the most brilliant PhD thesis ever written in astronomy. Interactions, matter and light. Interactions, matter and space-time. In the early 20th century, Albert Einstein's development of general relativity brought with it a new understanding of gravity. I don't know if you can read that back there. This is one of those silly cat things that says, I is in your space-time continuum, upsetting all your gravity and quantums and stuffs. Space and time, in Einstein's view, are inseparable and not absolute. There's no invisible force of gravity. Einstein didn't like the idea of what he called spooky action at a distance. But gravity is actually in the nature of space-time, which is like a fabric. It can stretch, bend, twist, ripple. It's dynamic and it can be warped by matter. In the words of physicist John Archibald Wheeler, space-time tells matter how to move, and matter tells space-time how to curve. One prediction of general relativity is that space-time should expand, increasing the distance between galaxies over time. Edwin Hubble, with the help of a janitor-become-astronomer's assistant named Milton Humason, is credited with the observations that illustrated this expansion. Although Hubble is credited with the discovery of the expansion of the universe in 1929, the Belgian priest Georges Lemaitre published a solution to Einstein's equations describing the expansion in an obscure Belgian journal 2 years earlier. When a translation of Lemaitre's paper appeared in 1931, the equations describing what has become known as Hubble's law had been removed. Lemaitre himself did that because he felt his distance estimates weren't strong enough to validate his discovery. That's integrity. That's integrity. When the response to Lemaitre's suggestion that the logical consequences of an expanding universe implied an origin at a finite point in time, well, that earned him the title Father of the Big Bang, but he was also accused by some that his deeply held religious beliefs led him to that view, and Lemaitre's response is very interesting. He says, as far as I can see, such a theory remains entirely outside any metaphysical or religious question. It leaves the materialist free to deny any transcendental being. For the believer, it removes any attempt at familiarity with God. It is consonant with Isaiah speaking of the hidden God, hidden even in the beginning of the universe. This is kind of like Lemaitre's complete rejection of any kind of God of the gaps theology. And you heard me say last night, you might have heard me say that the Big Bang is a terrible name for this. And it is because it imparts the misconception that the Big Bang is some kind of explosion that happened in empty space and sent shrapnel everywhere. That's not what we're talking about here. We're talking about a universe that started in a very hot, dense state, and space and time, as we currently measure them, sort of start at that point in time. So that's very different from space being pre-existent and this explosion within space. Everything starts at this point in time. So today we no longer speak of a center to the universe because there is no center we can point to. What we measure as space and time originated about 13.8 billion years ago. The vertical extent of this grid basically artistically depicts the relative size of the universe through its history, and the horizontal axis is a timeline that highlights some important developments. Might not be able to read those so clearly from the back of the room. So these developments occurred through interactions between the various constituents of the universe. The far left depicts the earliest moments in time when a period we call inflation produced a burst of exponential growth of the universe. The universe was initially so hot and so dense that not even atoms could exist. As the universe expanded and cooled, we see the emergence of the first particles, followed by the first atomic nuclei. It takes about 300,000 years for the universe to have cooled enough so that electrons could join with the nuclei of atoms for the first actual atoms to form. Electrons and atomic nuclei come together. And that's when the universe becomes transparent to light, so that light and particles can go their separate ways through the universe. Before this time, light and atomic nuclei bounced around in something of a particle soup, kind of like the deep interiors of stars. And this point of first light, the conditions of earlier times are imprinted on the patterns in that light, and they set the stage for later developments, like the formation of stars and galaxies. And so for several billion years, gravity slows the expansion of the universe. And more recently, that expansion has begun to speed up through something we call dark energy, and the name reflects the status of our understanding. We'll come back to that. We'll come back to that later. So here's another diagram with a similar timeline. It has a few more details. A lot of those details are not really the important points. What is an important point is that our sun is among the countless stars that have formed through the history of the universe and continue to form today. There are trillions of galaxies in the part of the universe we can actually observe. Each of those galaxies contains on the order of 100 billion stars. Over the past few decades, from observations in our galaxy, we've learned that most stars are orbited by worlds that are both like and unlike planets that orbit our sun. We call worlds that orbit other stars exoplanets, and we'll look at some amazing examples in just a bit. But first, let's look briefly at our solar system. Our solar system includes the sun and all the various kinds of worlds that orbit it. Worlds that we call planets, dwarf planets, their moons, asteroids, comets, and other small objects. The small rocky worlds are closer to the sun, including our beautiful Earth. And the larger gas giants like Jupiter and Saturn are further out, and Uranus and Neptune, which are considered to be ice giants. And those giant planets also have a lot of icy and rocky moons. And on this scale, the speed of light starts to become really important in the transmission of information. So the distance between the sun and the Earth is roughly 93 million miles. It takes light 8 minutes to travel that distance. So what that means is if there's a tremendous flare on the sun at this instant, we don't know about it for another 8 minutes. And as you go further out into the solar system, like when you consider transmissions from spacecraft like the Voyager spacecraft when it was in the outer solar system, that travel time is hours, not minutes. The nearest star to our sun, the next nearest star, is called Proxima Centauri, and it's not millions or billions of miles away. It's roughly 24 trillion miles, 4 light years. So even the nearest star, when you look up in the sky and see Proxima Centauri, well, you won't. You'd see Alpha Centauri if you were in the southern hemisphere. And the light you were seeing left that star a little over 4 years ago. And that's the nearest star. So when we look out in space, we're always looking back in time. So there's a lot on this graphic. So I'm going to sort of tell you the story of how our solar system, our understanding of how our solar system came to be. So the story starts with a cold, invisible dark cloud in interstellar space, the kind that I study with infrared and radio telescopes. At some point, the cloud is pulled together by gravity, possibly when it receives a kick from the outside, like a supernova explosion, that causes it to compress. The result is a flat, spinning disk of gas and dust. When enough material is accumulated at the center, the core of the sun becomes hot and dense enough to ignite nuclear reactions. In other words, to begin fusing hydrogen into helium. Now, the sun gobbles up about 99.8% of the material in that disk, and the remainder of that disk clumps together into bigger pieces that eventually become planets, dwarf planets, asteroids, et cetera, et cetera. Just as fusion reactions power the sun, they power other stars as well. So here's the periodic table. With the exception of the lightest elements, most of the natural elements on the periodic table were produced in stars. And the heaviest elements come from these supernova explosions where temperatures can reach several trillion degrees. It's also those explosions that distribute heavy elements produced during the star's lifetime. Without supernovae, those elements would be locked inside of dead stars. Hydrogen and helium together make up about 99% of the normal matter in the universe. We'll talk about what that means in a little bit. And it is the going joke among astronomers that everything on the periodic table heavier than helium is a metal. Now, of course, a chemist would not agree with that. But that's the way we talk about, since hydrogen and helium are so abundant in the universe. So I want to look briefly at one place today where stars and planets are forming. You can find a very large stellar nursery in a familiar winter constellation of Orion. At a distance of about 1,400 light years, the Orion Nebula contains a huge cluster of very young stars. And the gas that forms the nebula is lit up by the brightest stars at the center, stars that are washed out in this picture but are at the center of the Orion Nebula. And this is an image from the Hubble Space Telescope, first released 31 years ago. The dark foreground objects are roughly the size of our solar system, and they've been studied in great detail over the past 3 decades. We have a lot of evidence that they are forming planetary systems. We also have evidence that our solar system formed in an environment much like this, in the company of luminous stars that exploded and enriched our solar system in these heavy elements synthesized during a star's lifetime. The types of stars and planets that form are dependent on these wonderful interactions that take place over enormous scales in time and space. You might say that stars compete to grow, like siblings at the dinner table compete to get food and to grow. So this is where those words adopted from biology like nature and nurture work well. So we've looked at different interactions between light and matter, between space, time, and matter, interactions in the formation of stars and planets. Over the past few decades, using many different methods, those methods being outlined here, I'm not going to go over all of them, don't worry. We've discovered more than 6,000 planet-sized worlds, or exoplanets, orbiting other stars. The transit method is easiest to visualize, and it's also a method that brings us a lot of information about exoplanets. So occasionally, a planet will cross the face of its star. The planets in the star will be lined up so that a planet will cross the face of its star. Now, planets are very small. You don't see an eclipse, but we can detect the dip in the light output of a star when that happens. And so we'll come back to this a little bit more, what we can learn from those light dips. So this graph is, I think, a nice depiction showing the sizes of exoplanets relative to Earth. That's on the y-axis, versus the time it takes planets to orbit their stars, which is related to how far away they are from their stars. Now, this is a bit outdated because we're starting to fill out the frontier. The frontier is where we're talking about small planets, at large distances from their stars, and those are harder to detect. But this gives you a sense of the variety of planet sizes and distances from their stars. And one thing that's really interesting is that our solar system contains no planets in this size gap between the Earth and Neptune, which is 4 times as big as the Earth. However, there are a huge number of exoplanets that fall in that size gap. And in fact, this histogram gives you a better sense of just how many. So this is the fraction of stars with at least one planet and the size of those planets. So there are a huge number of exoplanets that fall in these categories of planets we call super-Earths and mini-Neptunes. And the super-Earths are particularly interesting because the people who work on planetary composition have shown that a large fraction of those worlds may actually harbor large bodies of water. We don't know that yet, but they might. And the reason that's so interesting is that water is essential to all life on Earth. So following the water is of great interest in looking for potentially habitable environments beyond Earth. Another very busy graphic, and don't worry, I'll condense it for you. This graphic is all about, the key here is that the blue circles indicate the relative amount of water each of these different worlds contains, either liquid or frozen. Now, some of these worlds are of particular interest in searching for potential subsurface extraterrestrial life in our solar system, including Jupiter's moon, Europa, which was just circled up there, Saturn's moons, Titan and Enceladus, and Uranus's moon, Ariel. A number of my colleagues at the Planetary Science Institute are involved in studies of these so-called water worlds in our solar system, not to be confused with the Kevin Costner movie, Waterworld. I study things a little further out, but they're involved with these fascinating studies of the composition of water worlds in our solar system. So as the number of exoplanets grows, so does the number of potentially habitable exoplanets. And I do want to interject some caution here. Potentially habitable doesn't imply inhabited or even necessarily habitable. What it means is that these exoplanets are at the right distances and they're the right sizes from their stars that suggest the temperatures may be right for the presence of liquid water. We need to learn a lot more about these worlds to claim habitability and even more to claim the presence of life. But with present and future observatories, we're filling in some of those gaps. And the TRAPPIST-1 worlds are particularly interesting in that they're the targets of many current observations, including observations with the James Webb Space Telescope. So I want to show you what the TRAPPIST-1 system looks like. This system contains the largest batch of roughly Earth-sized planets thus found outside our solar system. And what's so remarkable about these worlds is they orbit in very close proximity around a star that is much cooler and smaller than our sun, a star known as a red dwarf. Let's see, this joke is probably going to fall flat, but I used to refer to these worlds as, what did I say? Now, never mind, it's lost me. Like Snow White and the Seven Dwarfs, this was like the red dwarf, and the seven Earths and the red dwarf, or something like that. Sorry about that. Senior moment here. The green regions indicate the zones around the TRAPPIST-1 system and our solar system that are called the habitable zone, where liquid water might exist on a planet's surface. But because the TRAPPIST-1 star is so cool, relatively speaking, the habitable zone is located very, very close to the star. In fact, this entire system would fit well within the orbit of Mercury in our solar system. The JWST has been observing exoplanets in the TRAPPIST-1 system to characterize their atmospheres, looking to see if there are any kinds of molecules that are interesting in those atmospheres. TRAPPIST-1e is particularly interesting. It may be able to support liquid water on its surface, but the jury is still out. So I love this artistic representation of a family vacation on TRAPPIST-1e, where the worlds are so closely spaced that the other worlds in the TRAPPIST-1 system would appear as huge moons in each other's skies. So you science fiction fans out there, people after my own heart, we're living it now. We're living it. So this demonstrates how we go about detecting different molecules in the atmospheres of exoplanets. Now, this isn't an actual spectrum of an Earth-like planet, but it shows some of the important molecules that, in principle, can be detected using a technique known as transmission spectroscopy. As an exoplanet with an atmosphere transits in front of its star, its atmosphere absorbs light from that star at certain specific wavelengths that show up as dips in the amount of light we receive. And in the infrared, there are a number of these spectral lines that can tell us whether molecules like water, carbon dioxide, methane, and ozone are present in the atmosphere of the star. Determining conditions for habitability on exoplanets is an important step in searching for life beyond the Earth, and it's one important goal of the James Webb Space Telescope's mission. Now, again, we've been talking about exoplanets within our galaxy. Those are the ones we can currently study. However, there are so many more galaxies in our universe beyond the Milky Way. And over the years, the Hubble Space Telescope took some what are called deep fields, deep views into the universe by collecting light over the course of weeks or days from seemingly empty patches of sky. In this image, there are nearly 10,000 galaxies in the entire image. You don't see the entire image here. And that's only about 1/10 the diameter of a full moon. The analogy we've used in the past is imagine holding a dime at arm's length and projecting the eye of, is it FDR, onto the sky, and that's the small patch of sky we're talking about. Only the bright points with spikes are stars in our galaxy, and the brightest and most defined galaxies here are at distances of about 1 billion light years. The smallest and reddest are at distances of about 13 billion light years. As we go out to even larger fields that the Hubble observed, like fields the size of the full moon on the sky, the Hubble Legacy Field shows us about 265,000 galaxies stretching back to about 13.3 billion years ago, where every point of light, just about every point of light you see here is an entire galaxy, not a star. And the light from some of these galaxies comes to us from a very early time in our universe. Looking back in time, I said earlier that one important goal of the JWST was to study exoplanets. Another important goal is to study the formation of stars and galaxies in the early universe. And this chart compares how far out into space some telescopes and instruments are able to probe. The JWST, which has been operating now since December 2021, is filling an important gap in observations by probing the era when stars and galaxies begin to form. JWST is a much larger telescope than the Hubble. It can collect fainter light, and it also operates in the infrared. And because of the expansion of the universe, very distant galaxies are receding from us so fast that their light is Doppler shifted into the infrared. And so this diagram shows how Doppler shift works. Now, you all know about, I guarantee, you all know about Doppler shift when it comes to sound. You hear that train whistle approaching you at very high pitch, high frequency, and as it recedes into the distance, it stretches out to a lower frequency. Light does the same thing, so that things that are approaching us very quickly, the light is blue shifted to higher frequencies. As they're receding, the light is red shifted. On the very largest scales in the universe, because the universe is expanding, the more distant galaxies are shifted further and further into the infrared. So again, I apologize. I know the setup here, you can't really see this, but this picks out 4 galaxies observed by JWST. Each of these galaxies is sequentially further out into the universe. And this shows some spectral lines, how they are shifted further and further out into the infrared. The oldest galaxy that I'm aware of, or I should say the galaxy that we've observed furthest out in the universe, is this little red blip here. And in an astonishing find, astronomers have identified really powerful hydrogen emission coming from this galaxy at an unexpectedly early time in the universe's history. So there's a lot to learn here. In its 4 short years of observations, there have already been over 1,600 academic publications resulting from observations in the JWST. The Hubble Space Telescope has been operating since 1990. Anyone want to hazard a guess how many scientific publications there have been from observation using data from the Hubble Space Telescope? It wasn't a rhetorical question, but I'll answer it. Over 22,000 scientific publications, what we've learned from these incredible instruments. And these are but 2 of many observations that have complementary and overlapping capabilities of the many observatories that have overlapping capabilities to help us write the story of the universe. So, we live here. This is a shot from the Cassini spacecraft at Saturn, about 1 billion miles from Earth. Yesterday I showed the Earth from the moon. Today I'm showing the Earth from Saturn. There are roughly 200 billion stars in the Milky Way. There are more than 1 trillion galaxies in the observable universe. If you multiply the number of galaxies by the average number of stars per galaxy, you come out with 100 million quadrillion. That's a number with 23 zeros. For comparison, there are a mere 10 million quadrillion estimated grains of sand on all the combined beaches of the Earth. So there are roughly, give or take, 10 stars for every grain of sand on Earth. And we think there may be even more potentially habitable worlds in our universe. But wait, there's more. Physicist Marcelo Gleiser has said that the paradox of knowing is that it creates more not knowing. He's pointed out that as the island of our knowledge grows, so do the shores of our ignorance. The more we know, the more we realize how much more we don't know, and that should keep us all humble. Thus far, we've been talking about normal matter, labeled as atoms on that pie chart, which make up less than 5% of the contents of the universe. Dark matter and dark energy are 20th century discoveries. Their presence was inferred by their interaction with known things, and they make up about 95% of the universe. These two astronomers, Fritz Zwicky and Vera Rubin, were pioneers in studying dark matter based on observations that indicated that there was basically more gravity in galaxies and clusters of galaxies that could be accounted for by the normal distribution of matter. So dark matter is matter that doesn't interact with light, but its presence is inferred through its gravity. Dark energy was discovered through precise measurements of those supernova explosions in faraway galaxies that indicated that the expansion of the universe seems to be speeding up in time rather than slowing down. So you could think of dark energy as some kind of anti-gravity associated with this accelerated expansion of the universe. Now, dark matter and dark energy are what you might call known unknowns. We have no idea what they are at present, but their presence does explain many of the observable features of our universe. It also begs the question, what unknown unknowns might be lurking around the corner? There may be things out there that we have not even dreamed of. So the Vera Rubin Observatory, named after astronomer Vera Rubin, is another absolutely breathtaking observatory that began observations in Chile just a few months ago. In addition to shedding light, so to speak, on dark matter, the VRO is expected to help us understand the nature of dark matter better. So if you were here last night, you've seen this image before, and I'm here to tell you that you're going to see it again tomorrow morning, because this is an absolutely incredible image. This is one of the first light images from the Vera Rubin Observatory, which is equipped with the largest digital camera ever built. It's going to take detailed images of the southern sky for 10 years, covering the entire sky every few nights, creating this ultra-wide, ultra-high definition time-lapse record of what's going on in our universe. Basically, it's making the largest astronomical movie of all time. Not only will it provide many new discoveries, but it will track changes and dynamic processes in our universe. This image captures only a small section, about 2% of the Virgo cluster of galaxies. It offers a glimpse into a variety of different objects in our amazing cosmos, but you need 400 high-definition TV screens to display the entire image, which is roughly 45 times the area of the full moon on the sky. And the entire image contains about 10 million galaxies. And during its lifetime, the Vera Rubin Observatory is expected to capture light from about 20 billion galaxies. The observatory has also already discovered thousands of new asteroids, including those near-Earth asteroids that could serve as potential threats for impacts, for Earth impacts and threats to life on Earth. So some of the things we've learned, summarizing some of the key points: the universe continually changes via the interaction of its parts. Stars and planets form together through this delicate interplay of cosmic processes. Stars cook heavy elements needed for organic chemistry and life. Complex organic molecules, the building blocks of life, pervade interstellar space. The diversity of exoplanetary systems rivals that imagined in science fiction. And we haven't even scratched the surface of that. In fact, many exoplanets actually orbit 2 or more stars, not just one star. So Tatooine, Star Wars, there are planets that may actually be kind of like that. Life that interacts with its environment pervades almost every niche on Earth. If we discover extraterrestrial life in our solar system or a nearby planetary system, it would follow that life is probably common throughout the universe. However, not discovering it doesn't mean it's not there. The universe is simply too big. So there are many outstanding questions. Are we alone? A definitive yes is impossible. How frequently does life arise? We don't know. How frequently does intelligent life develop? We don't know. How frequently do civilizations that can develop symbolic language and build technology, how frequently do they develop? We don't know. How long do civilizations last? We don't know. What are the prospects for actually communicating with extraterrestrial intelligence? We don't know. So let's circle back and ask this question, how big is God? I mentioned that my Orthodox colleague doesn't like this question because ultimately the word big is inadequate to describe God. But considering just the people who believe in God as the source of creation sort of fall into 3 categories. Some believe in a God who created a small universe in time and space where only the earth is important. Some believe in a God who created an unimaginably large universe in time and space, but is indifferent to creation. Some believe in a God who created an unimaginably large universe in time and space, and yet maintains a personal connection to all that is, to everything. Which version of God is the most awesome? Well, I think 3 is the most awesome. Precisely because human beings can't wrap their minds around such a God. We understandably tend to equate power with indifference and impersonality. However, that's hardly the way the Gospels portray the way Jesus exercised power. We, I think, we sort of have to do this. We try to put God in a box. But science shows us that we can't even put the universe in a box. So ending with some reflections and questions. The universe is fertile. It has brought forth incredible diversity. Theologians have used these observations to develop ideas of how creation might both reflect and participate in God's creativity. The universe is an intricate network of relationships of which we are a part, not apart from. Trinitarian theology expresses this idea that relationship is somehow fundamental to the nature of God. Is there harmony here, I would ask? Being on the verge of placing a human presence on other worlds in our solar system raises many ethical questions. How should we regard any extraterrestrial life we might find? How do we explore space in a manner that's equitable to all without exploiting some? These questions underscore the urgency of bringing both diverse religious communities and cultures around the world, because the world is all of ours, bringing the world into conversations about how we should proceed with some of our knowledge and technology. So I want to recommend some books, both academic and popular. We'll get to the popular in a minute. These are books that explore some of the things we've been talking about further. Now, these are not light reading. Interactive World, Interactive God contains chapters written by scientists, theologians, and philosophers that reflect on this idea that the universe is interactive and relational. And it may interest anybody who wants to learn more about where some of this thinking is going in academic circles. Intersection of Religion and Astronomy examines the way cultural ideas about the heavens have influenced religious ideas and vice versa. I contributed chapters to both of those books. Astrotheology, Science and Theology Meet Extraterrestrial Life contains chapters written by scientists, theologians, and ethicists reflecting on the prospects for extraterrestrial life and communicating with extraterrestrial intelligence. Lutheran theologian Ted Peters, who edited this book, has been very active in establishing these kind of conversations. And there's a sequel to this book coming out in the next year or so, to which I also contributed a chapter. Human Becoming in an Age of Science, Technology, and Faith honors the career of Lutheran theologian Philip Hefner, who passed away just last year. It's centered around Phil's development of this idea of humans as created co-creators with God. And it contains contributions by many other prominent scholars who sort of reflect on the impact that Phil has had on their own work from different perspectives. So here's to the popular books. These books are written for more general audiences, and yes, they're all by the same author, who, as I mentioned earlier, won the Carl Sagan Medal for Excellence in communicating science to the public. Guy Consolmagno is an outstanding writer and speaker. Brother Astronomer: Adventures of a Vatican Scientist is a wonderful collection of Guy's journey and experiences as a scientist and a Jesuit. I'll share a brief story of one of his experiences during sermon tomorrow. The book, Would You Baptize an Extraterrestrial? And Other Questions from the Astronomer's Inbox at the Vatican Observatory, is written as a conversation between Brother Guy and Father Paul Mueller. And in case you're wondering, Brother Guy's answer to the title question is, only if she asked. I have yet to read this third book, and Guy's written more books as well, but this is the most recent, A Jesuit's Guide to the Stars, exploring wonder, beauty, and science. I have no doubt it's up to the standards I've come to expect from Guy Consolmagno. He's incredible. Highly recommend these books. So, finishing up just a few more slides here. Science is a process. It's not a collection of facts. We learn best by engaging with that process. Science is also empowering. It can help us improve conditions in our communities and across the world. Doing science with others can also help build bridges across different communities that might not otherwise get a chance to interact. So you've been gracious enough to invite me into your community here. If you want somebody to learn about your faith community, invite them to your church. If you want somebody to learn about science, invite them to participate in science. And I have some flyers about this at the front there. But just putting up this last slide, there are many platforms now where people of all ages and all walks of life, can participate in research projects along with scientists and other researchers. CosmoQuest is a platform that was developed by a colleague of mine at the Planetary Science Institute. One of the things you can do on that website is help scientists map other worlds in our solar system. You don't need any special qualifications. Zooniverse is the world's largest platform for projects, not just in the sciences, but also in the humanities. Projects that need a lot of human eyes. On images, on texts, to help annotate some images. Whatever area interests you, whatever research area interests you, you can find a project on Zooniverse. You can communicate with project researchers. You can possibly even make new discoveries. I know people who are normal, everyday people who've discovered new planets, new types of galaxies, even new baby star clusters in my field and things that interest me. And so the last thing, Periscope, on the slide there, is a research activity that's designed primarily for students in introductory astronomy classes. My colleagues and I developed this to give introductory astronomy students a research experience. So that's something that the QR code enables you to go to the website, learn more about it. If you happen to teach astronomy, you might be interested in signing up for our email list. We'll be recruiting teachers several months down the road. I'm also providing my email address in case you have any additional questions, even after this weekend. Feel free to email me. Check out these sites if they interest you, and know that science, like faith, is a journey. It's a process. It involves community, communication, and collaboration. Science doesn't diminish the mysteries of the natural world. Rather, it deepens mystery singular. Participating in science can be one of many different ways to honor creation's author. Thank you. Whoa. I don't know about you, but I'm dizzy.
Deep breaths, deep breaths.
Deep breaths.
I'm just, once again, last night I talked about how you helped open my theological imagination in regards to creation and just the diversity, the distance, the complexity, the wonder, the absolute joy in how the universe kind of unfolds in front of us. And as people of faith, how we attribute that to the God in our tradition revealed in Jesus Christ who loves you. And I always think, I often tell this story. Karl Barth, a very famous theologian, was asked, so you've studied all these things in theology, what's the most important thing? And his answer that's quite famous is he said, Jesus loves me, this I know, for the Bible tells me so.
Amen.
And what's so wonderful is you put that truth over against the truth that science helps us see in regards to the universe. And it is humbling and exciting, and I'm so grateful for you being with us. So once again, a round of applause for Dr. Grace Wolf-Chase.
Thank you. Thank you, Pastor Jeff.
I have just a couple quick things. One, don't forget our Living Legacy group makes this possible. And so there's a table out there that has all kinds of propaganda that you can look at. And if you want to help, and there's some people here in our presence that, in honor of folks who have died, have given gifts and the like. And those kind of opportunities just enhance our ministry. So thank you for the folks that do that, for our Living Legacy Committee, who also behind the scenes with our food truck and our coffee and our sweets and all those things. So God bless you and thank you. Also, just so you know, both last night and today's presentation will be on our website. So if you want to go back and go, now we weren't live streaming, but they will be available shortly. So go to our website and you can click. And so if you want to go back, what was that slide or what was said, you can kind of go back and look at those things. And of course, tomorrow, we're so excited to have you with us at worship. And you'll be preaching at both of our services. Then we have our famous chili and synonym rolls. It's not really potluck. Bring chili, bring synonym rolls. We'll gather in the back, and right there is the person who's bringing the vegetarian chili. So God bless you for that.
Thank you, yes. God bless you for that. Yeah.
And Dr. Grace will finish with us just some final remarks in the fellowship hall as we kind of finish up. That presentation won't be available required, but it's just kind of a 15, 20-minute, I call it a soft ending. So we look forward to tomorrow as well. So we do have a little bit of time for some questions, and this is how we're going to do it. I'm going to not give you the microphone, and if you can, as precisely as possible, state your question, then I will restate it for the sake of the recording, and then we'll let Dr. Grace Wolf-Chase answer the question. Does that kind of make sense? And I just kind of know if someone gives me, it's probably a pastor thing, someone gives me a microphone, I start going, well, let me tell you about, and so we want to make sure we get as many questions as we can today. So I will broker those. So
I'm even worse, Pastor Jeff.
Yeah. So maybe professors and lecturers
are the worst.
Yeah. So questions, thoughts, insights, things that you want a clarification on, things that struck you. please feel free. Is there anybody out there who has a couple? Yeah, let's start here and then we'll go over here.
I can't even remember what it's called, but the webbing, the net that seems to hold everything that bounces and that withers.
Okay.
Does it also expands?
So,
Okay, it's just so for the recording. So the question was this webbing, this net that kind of holds everything together. I think maybe that space-time conversation. Does it also expand?
yes, so you're referring to, what we refer to as the fabric of space-time is, again, it's a metaphor, of course. We say that space-time behaves like a fabric, because what does a fabric do? It can, well, some of them can stretch, it can bend, twist, ripple, and space and time are kind of interlocked together. I'm not about to teach a class in relativity right now, but they are like inexorably twisted, combined together, twisted together. So yes, the entire universe, in a sense, is you could think of as the cosmic web, and there are some visualizations that, like in the background to this, where I was talking about an interactive universe. That's a computer depiction of what they call the cosmic web. We see these large structures out in the universe, strings of galaxies and clusters. There are some shapes we see a lot of in the universe, and these long filaments are one of those shapes that we see on many different scales. So yes, that's mirrored on smaller scales where I study, where stars form. Stars also form in these like kind of long filamentary structures. So the universe sort of repeats patterns on many different scales. So that's a wonderful question. Thank you for that. And yes, space-time is expanding. How that's going to play out in the future, we don't have an answer to that question yet.
Thank you. Dan, you had a question first and then back to Bob.
It's a little bit off, and my wife thinks it's a loaded question.
Okay, so next.
In the Bible, they talk about there was a king, and I'm sorry, I don't remember which one it was. He did not pray to win the war, he prayed for more time. And I was given this piece of paper 30 years ago where NASA had gone back through and looked, and they found what they thought was a stoppage. And so that's how he got more time. Do you know anything about?
Okay, so I think maybe the story of Joshua when the sun stands still, maybe, but maybe you're thinking something else.
Well,
But the question was,
As he wanted to win this war, and instead of praying to win this war,
Yeah.
he prayed for
right. The question is, in the scientific community, has there ever been any observational realities that might suggest some of these celestial miracles? Is that fair?
I am not familiar with that. And that, I mean, that piece of scripture has been interpreted, I think, in different ways theologically too over time. What I will say is that I've seen people spend a lot of time trying to track down, trying to map astronomical or such events onto the Bible. And I think the place where I've seen this the most is with the story of the Star of Bethlehem, which appears in only one of the four Gospels, the Gospel of Matthew. And there have been entire academic conferences devoted to talking about what the star might have been, looking at astronomical, astrological, since the Magi or the three kings would have been probably Zoroastrian priests who would have been astrologers. And there has been a lot of academic work on this to sort of flesh out, the history of it, because there are lots of different interpretations of that story. Was it a natural event? Was it a miracle? Is it a symbolic story? And, there's so much effort has been spent on, the story comes down to like a few verses in the Gospel of Matthew, and it amazes me that so much effort has been spent on what this star was when it kind of loses the track of the big picture. In Matthew was specifically, and you can correct me if I'm wrong here, Pastor Jeff, at any point in time, Matthew was particularly speaking to a Jewish audience. The book of Matthew is introduced by the genealogies that you find like in the Chronicles, only he adds two women. I believe he adds Ruth and Mary into those Chronicles. And one of the important things about the story of the Magi was that, I think, to communicate to the Hebrew people that the birth of Jesus was for everybody. Because these magi would have been ancient astrologers, and the Hebrews did not practice astrology. The ancient Hebrews did not approve of astrology. So this was radical. The radical point of that story is that Matthew is telling the Jewish people, Jesus is here for more than just the Jewish people, more than just the Hebrew community. And I think if you get so worked up in trying to fit science into different parts of the Bible, there's a danger in losing the message of what's really important.
Yeah, thank you very much. Thank you. Bob, you have a question?
How does the concept of black holes fit into your...
Oh, that's great.
So,
Yeah.
So for people who are on the recording, how does the concept of black holes fit into the conversation?
Yeah, so even in an hour and a half, there's not time to talk about everything. And of course, I pick and choose because I study how stars form, so I'm more concerned with the birth of things than I am with the death of things. But yes, black holes are really interesting. So black holes are one possible end product left over from dead massive stars. So supernova explosions can explode like the outer layers of the star, leave behind an object that's so dense that gravity is so strong that not even light can escape. And we actually have observations now of light being bent around the giant black hole at the center of our galaxy and the center of an external galaxy. So there is now actually observational evidence both through analyzing how light gets bent around black holes, and also through these gravitational waves that I mentioned. What I don't have in this presentation is a demonstration of gravitational waves. So black holes, if there are two of them in orbit around each other that have formed through however they have formed, over time they can spiral in and merge into one black hole. Since black holes have so much gravity, they distort space-time around them. Something awful. They bend, warp space-time. And as they orbit each other, they send out these ripples in the fabric, these ripples in space-time. And these gravitational waves now can be detected by a number of Earth-based observatories like LIGO, the Laser Interferometer for gravitational wave observations. And the first detection they made was remarkable. So these gravitational waves, they sort of compress and expand space-time. And the first measurement that was made actually was the equivalent of the Earth being compressed and expanded like the width of an atom or something. I mean, this was such a minuscule detection. This is why in 1915, when Einstein made this prediction that they should exist, he said, yeah, there's this really interesting we'll never be able to detect these things. And that, so black holes are, yeah, they're incredible. They come in lots of different masses. And yes, there's a lot of evidence now that they actually do exist, that they're not solely a theoretical construction, but that they actually exist in nature. Thank you for that question.
Thank you. Yes, please.
I have a question about the singularity, the Big Bang. We have the dark side of the universe when there was no light. How much relation to people put in regards to the Bible where God said, let there be light, and actually referring to
Sorry. I'm sorry, Jeff.
Please, Dr. Grace,
I
give me
keep
my time. I have a
jumping the
microphone.
gun.
So the question was regarding singularity and what's oftentimes called the Big Bang, the beginning. How much conversation with the biblical witness of God saying in the first creation story, Genesis 1, let there be light, is tied up in those conversations about the varieties of light that you talked about in your presentation. Is that fair? Excellent.
So I'm actually going to give you Brother Guy Consolmagno's answer to that question. It's interesting, but he would caution that let's not lose sight of the fact that light has lots of different meanings too. And by saying, let there be light, is God saying, I'm doing everything out here in the open. You can see this. You can see what I've created. Like I said, when you try to fit various pieces of modern science into the Bible, it becomes very difficult. And one of the reasons it becomes very difficult is because our scientific understanding changes in time. What I'm talking to you here about, I don't think the universe is going to get any smaller, but picture going ahead in time 30, 40, 50 years. Our picture, understanding of some of these things like dark matter, dark energy, is liable to be a lot different. The dust never settles on our scientific understandings. However, having said that, when we read Scripture, we all bring our unique experiences into that reading of Scripture, and sometimes we find some little jewels that we resonate with on a personal level based on our experiences. So when I, for example, hear that quote from Job that I shared at the beginning of this presentation. Let me go back there. Where was I? Here we go. Okay, can you bind the chains of the Pleiades or loose the cords of Orion? It's interesting. And, I note this is a point of interest, not saying that this bit of science is actually being conveyed in Job. The Pleiades is what we would call a gravitationally bound cluster. Orion is what we call a gravitationally unbound association of stars. So when I read something like, can you bind the chains of the Pleiades or loose the cords of Orion, as an astronomer, my mind automatically goes to the Pleiades are chained, Orion is not. It's a little jewel that I can personally relate to, and I'm sure that there are people in this audience who are engineers, artists, who can relate to other things too, depending upon what their knowledge is, and that's the beauty of the Bible. There are lots of little pearls in here for all of us, but I always resist attempts to try to map scientific understandings onto what we read in the Bible, because that often leads to either misdirection or, I think, inappropriate readings of what wasn't written to be that way. Science as we practice it is only 500 or so years old. And why would God want to teach us science when there were more important things? Why wouldn't God speak to us in ways that we could understand at the time? Those original audiences, so I think I always try to, I can't do this very well, but I always try to transport myself back in time to the culture and say, what would I have heard at the time and what would have been meaningful to me? So, anyway.
Thank you very much. Good question. Thank you.
Very good question.
Anybody else? We have time for maybe just a couple more. Yes, Heather, please.
You talked about unfairly heightened the Earth and super Earth. What's the distinction between a super Earth and Earth?
That
So the question was, this is why we can't have nice things. So the question was, Dr. Grace Wolf Chase talked about Earth and super Earths and how many super Earths are potentially out there. And your question was, what's the difference between Earth and a super Earth?
And that is
Fair?
an absolutely great question, and it reminds me of similar question like, what's the difference between a planet and dwarf planet? And oh boy, we could go there. We could talk about classification in science and how we classify things based on properties that we consider to be important. So the only distinction between Earth and a super Earth is that super Earths are like up to 2 times the size of the Earth. And from the people who model planetary structures, and I'm not one of those people, there's reason to think that those so-called super Earths may harbor large bodies of water. But these classifications like super Earths, mini Neptunes, those might change in time, just like our definition of planets have changed in time. In fact, the word planet comes from planetes, which means in Greek, I believe, wandering star. So before the planets were considered other worlds, they were just considered stars that move differently. So these classifications have changed in time, and they've changed in time as we've learned more about what these things actually are. So maybe at some point in time, super Earths won't be called that anymore. But that's a great question that speaks to how do we form categories in science. And that's a fascinating, we could talk for another day just about classification in science. Thank you.
I'm thinking too, you talked about early on when we say the word creation and what that means, the same word from a faith perspective versus a scientific perspective. And so even the language that we use, that we assume we understand and is similar, actually may be interpreted in very different ways, which might be the cause of some of the tension.
It probably is the cause of some of the tension. And even as I was saying when I talked about my friend, astrobiologist Lucas Mix, who's an Episcopalian priest, even the language used across even different scientific disciplines these days is so different. It's like you need the Google translator, translate my email into German or Greek or something else. Problems also come in when people try to, and I've witnessed this a lot of times. I'm going to get myself in trouble here, especially because I'm being recorded, I know, but I can't tell you the number of academic conferences I've been to where you see the speaker, just pontificating about something and heads nodding, yeah. And you realize afterwards that the heads that were nodding didn't have the slightest idea what the speaker was really referring to. And so this was one of the things when I initially got involved in all of this, and I'd hear scientists and theologians talking at each other, I'd sit there and saying, these guys really aren't understanding each other very well. And how fascinated would it be to try to help bridge some of those conversations?
Yeah. Thank you. Got time for maybe one more question. Bob, please. We'll have 2 more. Dave, we'll let you have a question too.
It's my impression from reading that many of the people that were involved in the so-called Big Bang inflationary hot theory were avowed atheists, and the fact that it was leading them to a creation event was really troubling. Is that correct?
Okay, so the question from Bob was that, talking about the Big Bang Theory, but not the television show, people that originally a part of that conversation you had heard were devout atheists, and so the idea that this led to opening a door, my word, into a creation model was a bit troubling. And you want to know if Dr. Grace had ever heard about that.
So yeah, that's kind of like the shoe being on the other foot of what Father Lemaitre was accused of. Yes, Fred Hoyle, there were some cosmologists that were devout atheists, and people like Fred Hoyle who subscribed to the steady state theory of the universe, where creation is happening on an ongoing basis, however that happens, but the universe never really changes in that sense. So yeah, I mean, you know, people bring various preconceptions into the practice of science, and you know why we do that? We're human beings. You know, we're human beings that come from different experiences, and what people also need to understand is that just as there are many scientists of faith, there are many scientists who never went to church or never developed, how should I say, a more mature understanding of faith than like the second grade level. Just like there are people, the opposite side, who never really developed any kind of an understanding of what science is about. So, we talk from our perspectives, and what we need to have are conversations that start with building relationships that help us see the other as another human being who's coming from a different set of experiences, of perspectives. That's why I start with telling a little bit about myself, not because I think I'm a great person, but because I think you need to know a little bit about me and where I come from to understand some of those things. But yeah, you're right. I mean, there were people that objected to the Big Bang on those theological grounds. And then you have a lot of the Catholics I know that really don't like to map their science onto religious frameworks, that don't think that that's appropriate. And those are the Jesuits that I've sort of been brought up with since graduate school.
Yeah. Thank you very much. Dave, you had a question.
One of your open questions was, are there extraterrestrials? And I'm curious, with the Vera Rubin Observatory, will they be taking enough data to identify stars dimming because of perhaps a...
Like Dyson spheres?
like Pat's
Sorry.
star. So, just an open question.
So the open question was thinking about extraterrestrial life. Will the new telescope array that's online, Vera Rubin?
Vera Rubin Observatory, yeah.
Will that possibly give some insight into discovering things like Dyson spheres and Dyson spheres and other things that might be associated with, shall I say, intelligent life?
Technological life, civilization. Yeah. Dave, that is an absolutely wonderful question. And I'm going to start by just rudimentarily explaining what a Dyson sphere is, not assuming that everybody knows what one is. So one of the, Freeman Dyson, who I gave you a quote from Freeman Dyson earlier, years ago, had this idea that a really advanced civilization would try to trap a lot of the energy from the sun to build its technology, to build its civilization, and might break down or cannibalize material from its planetary system to build a large structure that would capture most of the energy from the sun. And therefore, as Dave says, you would not really see the star. I don't know about the Vera Rubin Observatory specifically, but there are programs looking at infrared data from some of these large surveys, looking for mysteriously bright, compact, infrared objects, because these Dyson spheres would emit a lot of heat. There'd be a lot of heat waste associated with them. But that's a great question. I don't know. I'd have to think a little bit about how the Vera Rubin Observatory might go about that. But I wouldn't be a bit surprised if there were ways that you could use that data to search for extraterrestrial intelligence. Even, you've heard of SETI, the radio search for extraterrestrial intelligence, but some of that is also being done with light and looking for bright laser emissions. So I could see the data being mined that way. In fact, that might be a great citizen science project after the computers have done a few go-throughs, because this observatory is going to yield like petabytes of data. I mean, the amount of data coming out of this observatory is going to be astronomical, bad pun. But yeah, great question. Thank you, Dave.
Thank you very much. Well, 2 hours we've been together, so thank you. God bless you. I know it's a lot of heavy lifting. Such a delight, and so informative, and just to ask big questions. And, from a faith standpoint, oftentimes in Bible studies that we'll do is I will talk about the fact that as a human being, I can only understand reality through time and space. And yet we worship a God who we declare to be the creator of time and space, which means God is beyond time and space. And so while these conversations around, the creation are so extraordinary, your phrase that you had brought up there, the unknown unknowns. And the unknown unknowns, especially when it comes to the reality of God, are beyond my ability to comprehend. And yet, we know that God is good. And we know that God is love. Amen? And God has created this amazing reality. So once again, a big hand. Dr. Grace Wolf-Chase, thank you for being with us.
Thank you.
Tomorrow, Dr. Grace will be with us at worship, both services, and then again afterwards for a short little closing. And she's going to be with our children for about a 15-minute presentation with our Sunday school children tomorrow as well. And so that's going to be a lot of fun.
And I'm going to give you a little preview of what I will be showing them.
Ooh, show and tell.
Show and tell. So I know you've got all these snazzy apps now on your phone. You can point at the sky and figure out what things are. But before there were apps, there were planispheres.
Yes.
So we're going to be talking a little bit about how to use one of these to find your way, and all the different colored stars and sizes of stars and everything that you can find in the sky. So
I remember having one of those. Anybody else remember having one of those? Yeah, I remember that. So that's a great memory. Thank you again. God bless you. Enjoy some conversation, hospitality. We'll see you tomorrow.
Oh, you're
Wonderful.